An actively exploited LiteLLM command injection vulnerability could expose the systems and keys behind enterprise AI gateway deployments. A lot of companies are starting to put an AI gateway between their applications and the model providers they use. That gateway might hold the OpenAI key, the Anthropic key, the Azure OpenAI key, routing rules, usage controls, and whatever policy decides which app is allowed to call which model. That makes it convenient. It also means that if the gateway gets compromised, the attacker may not need to break every AI application one by one. They may already be standing in the place where all of those applications meet. That's a concern behind an actively exploited vulnerability in LiteLLM, an open source AI gateway used to route requests across different large language model providers. CISA added it to the Known Exploited Vulnerabilities catalog on June 8th, which means exploitation has been observed in the wild. CISA describes it as an authenticated command injection vulnerability. The bug is tied to LiteLLM's Model Context Protocol test endpoints. MCP is the mechanism that lets AI systems connect out to tools and external services. LiteLLM included test endpoints that let a user check whether an MCP server connection worked. A user could provide a configuration object that included the command used to launch an MCP server. If an attacker had access to a LiteLLM proxy key, even a low privilege one, they could supply their own command and have LiteLLM run it on the underlying operating system of the target server. These target servers may have access to provider API keys, service tokens, routing rules, internal configuration, usage logs, and whatever credentials the organization uses to connect its applications to model providers. In a vulnerable deployment, compromising the gateway could mean gaining access to the keys behind the AI stack. There's also a more severe attack chain. Researchers have shown that this vulnerability can be combined with a separate vulnerability, a Starlet host header issue, to reach unauthenticated remote code execution in some affected deployments. In other words, depending on how the system is exposed and configured, the attack can move from authenticated to unauthenticated. LiteLLM fixed this vulnerability in version 1.83.7. Organizations running LiteLLM should upgrade to that version or later, and they should also make sure the Starlet dependency is updated if they may be exposed to the chained issue. If there's any chance your server was exposed, we suggest rotating provider keys and reviewing logs for suspicious MCP test activity or unexpected command execution.